Thanks, Sylvia, and hello, everyone. Hope you're doing marvelous today. We're here to take a look at cloud misconfiguration and insider threats. There's two big areas of security that are rarely explored in the same context, but as you're about to see, doing so is a must. Common cloud misconfigurations, including overly broad and permissive infrastructure policies, are a common attack vector when it comes to insider threats. But that also means that getting your cloud security correct up front with practical policies, using policy as code, and enforcing those throughout the entire software development lifecycle is going to be one of your best protections against insider threats. Here today to explore this in detail is Josh Stella, co-founder and CTO of Fugue, and Wayne Crissman, Fugue's Director of Security. And I'll be back later to facilitate your questions, so get those in early and often. All right, so let's get on with it, shall we? Over to you, Josh.
Thank you, Drew. Welcome, everyone, and thanks for joining us again. As you've heard, we're going to simulate some cloud misconfiguration attacks. In this case, today, the theme is insider threats. I'm Josh. Drew and I co-founded Fugue, and I'm the CTO. And today we have with us Wayne Crissman, our Director of Security. So we're going to go ahead and drill in here. So a little agenda for today. We're going to do a brief overview of cloud misconfiguration risks. If you've seen others in the series, this might be a little repetitive, but I think it's really important, especially for the new folks, to establish really what we're talking about and why it matters. We're going to go through a high-level overview of insider threats in the cloud with some categories. And by the way, this applies to every cloud. Public, all the big hyperscalers, so-called hyperscalers, but even private clouds, to be honest, depending on their features. And then we're going to simulate how insider threats exploit different kinds of cloud misconfiguration. And we've got this broken into two categories. The first one we're calling thieves and vandals, and I'm going to cover that. And then Wayne is going to cover the second category, which is the negligent and victims. So all of these insiders. And then we're going to summarize, as we go through, we'll be talking about tips for how to prevent these kinds of attacks or best deal with them. But we're going to summarize those tips at the end and then have a little bit of Q&A. So as Drew said, get your questions in. Okay, a little bit on cloud misconfiguration. It is a major security risk. So according to Neil McDonald at Gartner, nearly all successful attacks on cloud are the result of customer misconfiguration, mismanagement, and mistakes. Over on the right, you see 93% of respondents to a big survey we did last year from Fugue of 300 organizations that operate at large scale on cloud. 93% said they're concerned for a major security breach due to misconfiguration. That's good. Everyone should be, because the cloud is constantly moving and the attacker strategies are constantly changing. That should actually be 100%. And the cloud configurations you have are almost certainly constantly evolving as your use of the cloud changes. So types of misconfiguration our survey respondents were concerned with. 2/3 said identity and access management. I'm glad it was 2/3. It should be 100%. That is a massive area of potential exposure to risk by attackers. And by the way, a lot of these things are inobvious. They are kind of in the nooks and crannies of how you configure cloud. And when we talk about cloud configuration, we mean what access privileges do things have? How are the individual, the next category security group rules? How are ports and protocols open or closed? What are dangerous ports or protocols? 59% said they're concerned with security group rules, firewall rules, ingress rules, basically. They should be. There was just a breach of customer data in recent weeks where an Elasticsearch cluster was stood up as a cache of data, and they just didn't know that by default, Elasticsearch has no authorization or authentication turned on in many cases, and it was open to the internet. Well, that's a huge security hole. So then object storage access policies, another big one. We'll touch on that a little bit today. We'll be touching on all this stuff in one form or another today. This is like, do you have public S3 buckets or object storage, blob storage? But it also goes deeper than that. That's what everyone worries about. There are also things like bucket policies you can put on object storage to prevent breaches. And then, of course, encryption in transit. So I think it's important to understand that this is a large, complex, and nuanced landscape of cloud configuration, misconfiguration, and exploits. And the bad guys are really clever. Okay, hacker strategy has evolved in recent years. Kind of in the pre-cloud era, and this still happens, by the way, attackers would go after a particular organization. They would target that organization, look for vulnerabilities to exploit. And as we'll get into later, this is particularly nasty for the victim style of insider attack, where somebody is exploited through targeting, often through social hacking mechanisms, and then are exploited in their vulnerabilities that they have in the system that they have access to. So the Sony breach by North Korea is a good example of this, right? State actors, big sophisticated attackers. So those still happen, but the vast majority of what happens these days is automated, and it works differently. Over on the right, what you see are folks, bad guys, black hats of all varieties, are using automation to just go look for anything that has a misconfiguration with a public IP address and or DNS record. Obviously, you can't have, you can have an IP address without a DNS record, but not the other way around. But basically, if you have an endpoint facing the internet, bad guys are hitting it. A true expert on the topic, when I asked him how quickly he thinks things get hit, he said on average, according to his research, about within 7 minutes of an IP address being exposed to the internet, it has been scanned by at least one bad actor for vulnerabilities. So if you're wondering, when do you need to bring security in for cloud misconfiguration, it's before you put stuff live, because you might only have 7 minutes before bad guys identify any mistakes you've made. And then they get a nice shopping list of organizations to go and target. And we've seen this in numerous recent breaches where multiple organizations were able to be targeted, and particularly juicy ones for the bad guys were picked out. So the bad actors are using automation to find and exploit your cloud misconfigurations. And that, by the way, means you need to as well, because humans are much, much slower than computer programs running in the cloud. So let's talk specifically, that was our overview of kind of cloud misconfiguration in the problem space. Let's talk specifically about the insider threats. We've organized this, Drew has organized this into a 2x2 matrix. I'm sure our CFO, Gus, who went to Harvard Business School, they love 2x2 matrices. And this is a really good one, so Gus will be happy. On the y-axis, from the bottom to the top, we have unintentional threats. So in other words, insiders that don't intend to be bad actors, and then intentional threats, insiders who intend to be bad actors. And then on the x-axis, from left to right, we have persistent threat types, things that last for a long time, that are ongoing, where your approach needs to be more like finding out what's happening at any time and monitoring it and figuring out, in the case of negligence, are people making errors consistently? In the case of an internal thief, do you have somebody inside who's continuing to try to do malfeasant things? And then on the right, we have episodic. So by episodic, we mean like one big bang event. Somebody grabs all the data or blows up the system. So we're going to cover these going from the intentional to the unintentional. I'm going to cover the intentional, and Wayne is going to cover the unintentional. Okay, let's talk about the thief. These are our terms, by the way. Let us know if you like them or not. We thought they were appropriate. So what we mean by a thief is an internal actor, bad actor, who is intentional and persistent. So an internal bad actor who steals and misuses organizational assets. So these kinds of resource misuses, asset misuses can include things like changes to application function, such as like siphoning off data or money. If you've ever seen the movie Office Space, they make a joke of this, like every transaction will steal 1/100 of a penny, and they get it, the decimal place wrong, get busted right away. Well, those things happen, right? I'm not saying they're common, but they do happen. It is definitely a vector, especially folks in sensitive and regulated industries need to be concerned with. I'd say the more common ones are 2 and 3. Collection of organization data for nefarious or unapproved uses. Taking data that belongs to the organization and doing something else with it. Either fraud or selling that data or extortion with that data, etc. And this is actually not all that uncommon. And then finally, probably the most common, use of company resources for self-dealing, such as using compute resources for crypto mining or other kinds of kind of resource appropriation or theft. So this is what we mean by the thief, people who do this kind of stuff, who are insiders and intend to stay and keep doing it. So how do they exploit misconfiguration? First and foremost, the cloud at scale is really difficult to get your head all the way around and have full knowledge. So if you think about, it's very common for Fugue customers to have tens or hundreds of thousands of cloud resources. And when you have that much stuff, and each of those resources, of course, has usually hundreds or thousands or more ways it can be configured if you combine them. So that yields a very, very large number of things to keep track of. And the thief can often hide their use of cloud resources or their misconfiguration of them in like a large cloud computing bill, just be kind of noise, in the signal, or just go unnoticed by being clever because the old kind of first generation security scanning tools aren't looking for some of the subtle ways bad guys misconfigure cloud resources. So that's one of the ways they manage to exploit things. The second, the storage services on the cloud are really flexible and powerful, and they often operate in ways that are unfamiliar to security teams who came from the data center world. So back in the data center world, if somebody's exfiltrating data, they probably need to do it across the so-called perimeter of the corporate network. That's not as true in cloud, and there are lots of ways to get data out of cloud that don't cross the kind of virtual network so-called perimeters. I've never thought perimeter defense was achievable, and it was a bit of a false sense of security, but on cloud, that's just blown away. So bad guys, internal bad guys who are trying to steal data, know how these things work, and often security teams are behind the times a little bit, and also don't have adequate tooling to solve for that problem. And then finally, relatively small changes to cloud configurations can create large opportunities for nefarious activity. Going back to that tens or hundreds of thousands of resources times hundreds or thousands or tens of thousands of configurations, and you're looking for not just needles in haystacks, but particularly shaped pieces of hay in haystacks. It's really hard to suss all that out without tools like Fugue. So how do we stop the thief? I should put the big caveat on any security discussion. Stopping things is the desired goal, but bad guys are clever. So it's always an escalation game, right? You're always trying to stay one step ahead and continuing to do it. So there's no like, if I do these things, it's stopped and I can forget about it. This is an ongoing process. The first thing is you have to know your configurations and not just be looking at the cloud infrastructure and configuration of it as I have a list of things that I think are dangerous. That is actually a very naive approach. It is, again, the one taken by most security tools out there, but it is naive, and that's why we're still seeing a lot of these exploits. You really need to know every configuration of every resource down to every attribute, and at all times. So that means automatically over time the same. And then you need to track changes to those configurations down again to every attribute of every resource. So without automation of this, And in fact, automated remediation, in other words, correction of drift, you're going to be kind of at the mercy of the thief, because they're counting on you not knowing everything that's running and being aware of it, and not knowing if every attribute is configured correctly, because again, subtle changes to configuration can open large security holes. And then if you're not doing automated remediation, if you're not having a system, a tool automatically fix stuff that gets misconfigured, they have windows of opportunity to keep abusing the system. And by the way, I've seen these last for years. Misconfigurations in cloud last for years. There was recently a breach where, and Wayne will talk about this a little bit too, where some database credentials were found on an EC2 instance that had been forgotten about for a very long time. Okay, switching from the thief to the vandal. The thief is the person who's inside, misusing resources, stealing stuff, fraud, etc. The vandal is an internal bad actor, an intentional bad actor, who damages organization assets, generally in a single episode. There are exceptions to that, but often is the case. So the person who gets fired, for example, and decides to deny access to legitimate actors. That actually happened in a large city on the West Coast a number of years ago. A system administrator didn't like what was going on, had the ability to change all the root passwords of systems, and then tried to extort that government. Another example would be destroying data. So destroying data is one of the most harmful things you can do. A third would be like damaging applications or systems. So the vandal is somebody usually who's angry and wants to do harm, and believes that they are kind of the smartest person in the room, and intends to do harm kind of on the way out the door usually. So how do they do this? Overly permissive access to configuration of cloud resources, right? You do not want, there should never be somebody who can change root on everything. That's just a really bad idea. And in fact, you should have policies that prevent that, right? So number two, exploit inadequate security policies and enforcement of those policies. So part of this is technical, and part of it is kind of social, is organizational. And then finally, they are relying on the inadequacy of use of automation in the organization to have resilient cloud infrastructure. So how do you stop the vandal? One, separate concerns and privileges. Make sure access to delete permissions of snapshots and backups is closely held and is not shared by the same person who can, for example, have administrative access to the live functioning databases and data sources. So separate those concerns. There was, well, Wayne will get into it later, but there was a really devastating attack a few years ago, I think in 2014, where all the data and backups for a really promising startup were deleted, and that company went away. So you never want a single set of credentials to have access to both the production side and all the backups and so on, because your data kind of is your life in this world these days as organizations go. And the cloud providers understand this, so they provide some really cool data retention features for cloud resources like blobs and S3, where even if you do a delete operation, it actually is still there for some time so you can respond. And then finally, implement automation in the form of self-healing infrastructure tools to make cloud resources really resilient to vandalism. One of the beautiful things about cloud is because it's all API driven, we can do nearly full automation of restoring correct operation. All right, I'm gonna do a pretty quick little demonstration here of just some vandalism and some self-healing because Wayne has a bunch of stuff to tell you about, and he's probably got a little bit cooler stuff to demo than me. So I'm gonna jump over here, and first, let's stop this. Okay, what I'm showing you here is a visualization of some cloud resources. This is our product, Fugue. This is not a Fugue pitch, but we're gonna use Fugue to show you how self-healing works. So I've got several VPC networks over here with different subnets and security groups and different data storage S3 buckets here. And of course, back to the point of knowing what you're running, this is why Fugue builds these automated visualizations for you, is being able to visualize what you have going on. So real quick, I'm going to jump from Fugue into, I probably need to start a new session in my AWS account. I'm just going to do some vandalism. So the scenario here is Drew has finally gotten sick of me. And as my co-founder, he says, Josh, I don't want to work with you anymore. So I go into AWS. Of course, he wouldn't do that and I wouldn't do this. But that's that kind of scenario, right? Somebody's on the way out the door, they're bitter. I'm going to go in and break stuff. I'm going to remove all the tags from this VPC network, and I'm just going to make it so the security group doesn't even work at all, and the application is broken. Now, I'm doing this quick. In a real world, I would do more destructive stuff than that, but that's enough to show the point. So real quick, because Fugue here is configured, and there are other ways to do, well, there are other ways to do something similar to this, not exactly what we're showing. We're the only thing that has full auto remediation and self-healing. In Fugue, I've just selected this, everything in this cloud environment, if it gets broken, fix it, and I just check a box. And I'm just gonna go over here and tell Fugue, go look at it right now, rather than waiting the additional 5 minutes or so that it would normally take to do that. So let's go find, I'm using a little tool called Postman, which is a API interaction tool, just a handy tool for that. Oh, and before I tell Fugue to go fix everything, let's just look real quick here. You can see this security group, I really broke this. This is not like a fake demo. I'm going into the AWS console and really breaking stuff, and I really deleted those VPC tags. I could also do things like create really broken routing tables in VPCs. There's all kinds of nasty stuff I could do. All right, this is saying Fugue is already scanning that environment. So hopefully I caught it at the right time to show that remediation, and it looks like it's still working on it. It should catch it in just a minute here. So why don't we do this while we're waiting on, well, let's see, did we get it? Nope, we're still waiting for a few minutes. It's still doing this scan.
And Josh, what does this scenario look like if you don't have kind of automated remediation in place? Like, what kind of fire drill are you looking at?
Oh, that's a great point, Drew. So if you don't have automated remediation, the best case scenario is that within usually some period of hours, you'll get an alert. Sometimes it's shorter, sometimes it's longer. You'll get an alert somewhere. A ticket will generate somewhere saying something changed. Maybe you're following CloudTrail logs, for example. Those can take minimum, usually 15 minutes, but can even take hours. And then a human being has to go investigate it and figure out what happened and then decide what to do. Whereas with an automated remediation mechanism like this, it's just going to, in a completely automated way, fix those things for you. So why don't we do this? We'll come back to that after, since AWS's APIs, we're all at the mercy of those, and I'm running in US East, so for better or worse. Why don't I go ahead now and turn this over to Wayne, and we'll see how that automated remediation worked shortly. Wayne, I'm going to stop sharing and hand the control over to you.
Perfect. Perfect. Thanks, Josh. I'm going to start sharing my screen now. Okay. You should all be seeing the negligent, the first slide on that. So before we dive into what all these things mean, we want to make a distinction right up front. It's hard to talk about negligence without sounding like we're pointing fingers, and that's not what we're doing here. We recognize that we're all humans. We all make mistakes. We're not talking about the one-off mistakes or the misconfiguration here and there. What we're talking about is the threat of negligence, not necessarily the risk of a mistake. So we'll define these now. Negligence can be one or all of the following: repeated misconfigurations against industry best practices and established policies. Most likely your organization has some kind of policy and it's there for a reason. And the negligent insider, willfully ignores them. Or maybe in the worst, and even worse case, is not has not read them. Another attribute could be that they are not students of history, or more likely, not practitioners of what history can teach. And what I mean by that is, Josh has mentioned a couple of breaches, and we're going to talk about them in a little bit more detail in a second. All the details of everything that's ever been made public is out there for all of us to learn from, to take those lessons learned and to put them into practice for ourselves. The negligent insider doesn't necessarily do that. And then finally, this one that I still kind of chuckle about is the cowboy. As a former boss of mine used to say things like, so-and-so would wander off the ranch, or IT is not like the Wild West. The cowboy is that person who tests in production, who blazes through confirmation dialogues without really reading them or possibly understanding what's there, using force flags all the time. That's the kind of thing that we're talking about here. So how are you at risk in this situation? And something you're going to notice is there's a lot of overlap, not only in terms of the different types of insider, but also the things that put you at risk from external threats as well. So these first two, overly permissive access, providing overly permissive access to resources, marking data stores as public. There are attributes of cloud service providers. We're going to look at AWS specifically. You don't have to build anything or opt into anything. AWS will try to warn you if you try to make these kinds of configuration changes. And chances are it's probably not the right kind of change. You don't have to do anything extra, it's just built for you. And we're going to take a look at that in just a few minutes. Leaving orphaned infrastructure. As Josh mentioned, there have been a number of recent breaches where they included hacks of long forgotten EC2 instances that were exploited, taken advantage of, and they had access keys or API keys embedded in them, database credentials, and so forth. Accidentally deleting, ignoring confirmation, like we talked about, insufficient testing, not adhering to policies. And then kind of finally, one thing that I'll show in a minute is kind of like InfoSec 101, encrypt all your secrets, right? Protect everything that's sensitive to you. And so pushing plain text secrets to repositories, there are scanners that watch public repos on GitHub that were looking for things like AWS access keys and things that look like passwords. Those scanners are out there and they find within minutes anything that's pushed to a public repo. So how do we prevent that? You need to make the wrong thing hard to do. And we're going to look at a couple examples of that. I'm going to show you some command line tools to prevent source code leakage. Secrets and source code leakage. We're going to look at some provider features. I've said we're going to look at AWS. We're going to look at versioning. We're going to look at how to protect some of your backups. We're going to look at how to build safeties around those. We're also going to look at, we're going to look at in a little while, but also use policy as code, promote advanced policy remediation, just like we talked about with infrastructure. You can achieve the same thing with policy, and we'll look at that as well. So we're going to shift to the victim. A victim, quite simply, is something or a thing, an organization that's targeted for some kind of attack. What's really interesting about victims is that they can often become the scapegoat for other kinds of threat actors. For example, the thief may impersonate someone, causing that person to be the victim. They may steal something, and initially you may not even know who the thief really is. You may suspect the victim. Or maybe the vandal wants to cover their tracks. So, they're very disgruntled about being fired, so they impersonate an identity, do a bunch of damage, they get out the door, and they might still be able to use your company as a reference, right? Or something like that. And finally, something that's really important to keep in mind is that all of us, one thing that's very unique about victims, we may not all be thieves, we may not be vandals, but we can all be victims, and that's something that's really important. Anybody can play this role. So how is your cloud put at risk? And what I thought would be a good thing is if we look at a couple of examples. Depending on the type of access or the type of destruction, we could be talking about a total destruction. We could be talking about a company-ending episode, thinking about code spaces like Josh had mentioned earlier, source code and repository provider, all hosted on AWS. There was a guise of a DDoS attack where at the same time an attacker was able to gain access to CodeSpace's AWS console, and when they tried to take back their control of their console, the attacker began to delete as much as possible. We're talking EBS volumes, all of their backups, S3 buckets, and the list just goes on. And the company was not able to recover from that. In their public statement, they confirmed that no servers were breached. And as far as we know, there were no application 0 days that were exploited. And it's possible that passwords were guessed, but it's more likely that they were socially engineered, either by a phishing scheme or somebody called on the phone and was very good at social engineering and managed to get access to the accounts in that way. The destruction could mean leaking PII, company intellectual property, or internal correspondence. Sony, we've talked a little bit about already, where it seems like least privilege, as Josh talked about, was not necessarily observed. In this case, some high-level executives were spearphished, either sent a malicious link to a bad website or had an email attachment that had some embedded malware. But in whatever the case was, this malware got into their network, likely performed some sort of privilege escalation, and deleted some data, stole others, encrypting that data on its way out the door. So the only thing we know about was what was made public. And what we know was made public was personally identifiable information about the company's employees, pre-release of some movies, sensitive internal documents such as marketing decks, and so on. So how do you stop this? How do you limit this blast radius? Rule number one, right, is protect your email. So we, the IT industry, have placed a lot of importance on our email. I mean, think about it. Where do your password requests go? Our recent requests go? What is your identity on a lot of your social websites, your banking, any medical sites you might happen to use? If an attacker gains access to your email, they can pivot to any number of services that you might happen to use. If you're like me, you probably don't delete everything that you should, or you don't empty your trash often enough. And so there's potentially a record of services that you use this email address for. Limit the scope of individual roles. Josh talked about this earlier. This is what least privilege is all about, and we're going to just look at a brief example of that. Use multi-account strategies. Think about security as being like an onion. Every layer you have security built in. Logically separate your business functions across multiple accounts to contain breaches. So your main app functionality might live in one account. Your data storage might be in another. Backups are in a different account. Logging might go to a separate account. Encryption keys go somewhere else, and so on. And you can control access via policy and sharing settings to limit the exposure that you have. And so if one account is breached, the whole app is not compromised, and you can contain the threat there. Teach. Security training, regular training of your employees. Phishing exercises. Try to phish your own employees. It's much better to find out who clicks on those bad links, who visits those bad websites, who gives out their password over the phone. It's better to find that out from your internal security team instead of a threat actor or something that can end your company. Establish your policies. Establish what your response procedures are going to be like. Practice those in game days, and then furthermore automate those kinds of things, as much as you can. So thanks for sticking with me. So now I'm gonna hop out of the slideshow, and I'm gonna go do the fun stuff. So for the most part, we're gonna do a little bit of review of what some of these threats are, but what I'm mostly gonna be showing is ways to prevent these things. I'm gonna show it to you in action. So first, I'm gonna hop into a terminal, and what I've simply got here is just a GitHub repo, or a repo using Git, just called repo. I've got a README, and I've got some source code. So what I want to talk about is a tool called Git Secrets. And there's a lot here. I'm of course not going to read that all out. But what this tool essentially does is once you set it up, once you install it as a commit hook into Git, it will look for sensitive material that some of it's pre-configured if you choose to install those options, or you can define your own, and it works mostly on regex. So what I'm going to do, I've already got it installed. You can grab it via Brew if you happen to use Brew, but there are several other places you can get it. So I'm going to do Git Secrets and install it. And I already have it installed, so I'm just going to force the reinstallation so you see what the output looks like. All right, so I've got a few lines. Looks like everything was successful. So this might be some repository you already have, and you want to know, do I have any secrets right now? right? Actually, sorry, I need to Git Secrets, register AWS. And what this is going to do is look for access keys. So the keys to the kingdom, so to speak. This is the kind of thing you never want to put in source code. You never want to put them anywhere. You want to encrypt these things. You want to stick them into a secrets manager of some kind and refer to them. Sorry, 1 second. I got a little bouncy. Don't know why that's happening. Okay, so one thing that's nice about Git Secrets is you can scan your history to see if you already have anything out there, because maybe you just found this tool and you've got hundreds of thousands of commits, right? So I'm going to scan my history to look for any secrets. Oh, and lo and behold, in a file, it looks like I do have something that looks like an access key and also a secret key. So I'm gonna get rid of those. Now in the real world, I would also go and rotate those credentials. These are not real, so these are just some random typing of the keyboard to make sure it fit the regex. So feel free to use them all you want, but they don't work for anything. So, all right, great. So I'm going to check that. All right. All right. So I remove that secret. And now, let me see, let me pull up the source code here. Oops. Hopefully it's still on my clipboard. It is not. Well, I'll tell you what, here's what we'll do. Just pretend, I thought I had this right, but I messed it up. Just pretend that I have some Go code here that looks right. And I've just made some changes to source code. I'm gonna add this because I made some changes. And hopefully the demo guys are nice to me. And it should stop me. Yeah, so this is just to show that it also works after you've installed the tool. I have tried to commit source code that contains secret information, access keys, but the tool has now stopped me. So I'm starting to raise that bar. I'm starting to make it harder to do the wrong thing, which is to add secret information into my source code. And there are a number of ways you can fix this. If this is a false positive, you can mark it as such. You can also use a long option no verify, which is essentially like a force flag. So you should not use that everywhere. You should always just use git commit. Don't use no verify unless you really, really want to. So that was just one example. So next, I'm going to try to move through this kind of quickly so we can get to Q&A. And then also want to check on Josh's remediation. Let me jump over here to Fugue. So what we're going to be looking at, just ignore the network for now, is a few buckets. You'll notice here I've got a couple of them in red, and I'll show you what that is violating in just a minute. So what I'm going to look at first is taking a private bucket. I'm going to show you what's built into the system, built into AWS for trying to make things public. So I'm going to open the bucket, look at the permissions, and this block public access. Let me blow up my font here. Hopefully that's legible. I'm going to attempt to just remove this safeguard. And if you're not familiar, block public access will, any object or bucket settings that makes this bucket public, this will override that. I'm removing this safety. And so just by clicking save, I have to type the word confirm just to do this. AWS is trying to warn me that, hey, you're about to do something bad. I can still do it, but they're trying to stop me from myself. And then if I want to go into the the ACL list here and I want to make it public for everyone, as soon as I check this box, AWS again is trying to warn me. So this is a feature that I didn't have to build. This is just built into the cloud service provider. So I'm going to jump back out of here, go back to S3. We talked a little bit about practicing least privilege, separating concerns. And I just want to show you a quick little example. So what I've got here, these are just, you can ignore these. I've got a few roles here. This is just the role that Fugue uses. You can ignore that as well. I've got EC2 admin, EC2 auditor, and S3 auditor. Now you can imagine many, many roles. The important thing to note here is that there's a separation of concerns here. I have someone who is an EC2 admin. I have a role who's an EC2 auditor. Any auditor cannot make modifying changes to EC2. And furthermore, any EC2 admin cannot make any changes to S3. I don't have an S3 admin here, but you can imagine and the analog here for S3. The point is separating those concerns. So if I do have someone who's either negligent or a vandal, and they can assume one of these roles, right? They can do damage to EC2, but they can't delete anything in S3. And that's really the point here. I was going to also talk about bucket versioning. So I'm going to look at my version bucket here. And so I'm, excuse me, let's say I've just become the victim. Someone's going to come in and start deleting my data. So they come in, they're going to delete this object, right? Now it looks like it's gone. I have an option that the cloud service provider AWS has enabled that I've turned on for this bucket called versioning. And I'm going to toggle this option here. Instead of hiding all versions, I'm going to show all versions. So, excuse me. When you turn on versioning for a bucket, whenever you delete an object, the object is not really gone. What's happening is that behind the scenes, there's a delete marker set on that object. So anytime you try to get the object via, just a typical HTTP GET, it'll look like the thing is actually gone, but you can perform a different API called a get specific versions and also restore versions. So quite simply, to restore this version, to restore this object that was just deleted, all I need to do is delete the delete marker. And if I go back to hiding all my versions, my data was never actually gone. I might have had some 404s for a minute until this was restored. But this is another thing that you can easily just undo. And I didn't have to really do anything. Again, I'm raising that bar. I'm making it harder and harder to do the wrong thing. So I wanted to also show about buckets. This is the last thing, excuse me, that I'll show in the console before I jump back to the visualization. So here's my backup bucket. I have versioning turned on, so that's one safeguard. An additional safeguard that I've done is I have made it impossible for someone using what's called a bucket policy to delete the bucket. And I've also made it impossible to delete an object. So this is what Josh was talking about, separating concerns, never allowing the same person, the same entity, being able to delete your buckets or delete your backups. This takes it a step further and not allowing anybody to delete your backups. So I want to come here. You know what? Let me clear these out real quick so they don't mess us up. So my backup bucket, I'm just going to delete this bucket. And again, AWS tries to make it hard to do the wrong thing. You have to be really sure you want to delete that bucket. So the bucket's still there, and it looks like I got an error. Delete bucket failed. If I look at the details, I'm denied. So there's no principal NIM that can delete this bucket. And that's just another safeguard, just another way you're making it harder and harder. I could further enforce this by adding an additional bucket policy attribute or action, excuse me, to modify the bucket policy. So I could really lock this down by not allowing anybody to even modify the bucket policy, because that's another thing I could do. I could delete this bucket policy, then delete the bucket, but we're getting into multi-steps. You have to exploit multiple, you have to perform multiple actions to do the wrong thing. So again, continuing to raise that bar. So what I wanted to get back to, oops, jumped ahead, is why are these red? And we talked about policy as code. We've talked about it a couple of times. The reason my unversion bucket is non-compliant is because I have a rule that I created that requires that versioning must be enabled. And my private bucket also has the same problem. And I've done this using a custom rule. So Fugue has the ability to just turn on compliance families, but if you would rather keep, if your posture is just different from what compliance families have, I've just created a simple custom rule that just requires versioning to be enabled. And that's why this is a deny. I'm sorry, denying anything means to mark it as failing to be in compliance. And that's why you see this as non-compliance over here.
And Wayne, if I could just piggyback really briefly on that.
Absolutely.
We just made a big announcement that Fugue is now supporting Cloud Native Computing Foundation standard called OPA, Open Policy Agent, for all custom policy as code. So the code you just saw is OPA code. It's open source standard policy as code from Cloud Native Computing Foundation standard. I think we're getting really short on time, Wayne.
Yep.
Maybe we can just jump into Q&A. We had a summary slide, but Drew, Did we get any questions?
We have a couple, and you know, yeah, we can leave this up on the screen too, or get back to some of the the tips, which I think we've covered most of them. So first up, what are some methods we could use to find persistent insider threats right now?
So I'll take this first, and Wayne, chime in if you have some other ideas. So persistent insider threats, you know, the two varieties are negligence, right, and the thief. And both are kind of forms of configuration management for detecting those things. I think this is a general theme around the persistent threats. There's the human social aspect, like, you know, policy and so on. That is mostly preventative. But the configuration of things is how you're going to find if people can do these things. So Wayne showed how you can go and look in certain cases for like access keys lying out there. There are also places to go and look in things like your old GitHub repos. Other places we've commonly seen access keys found to be used in exploits are on things like forgotten about, you know, so-called orphaned or zombie resources in the cloud, like an EC2 instance where IAM roles weren't being used properly and instead the credentials were saved to a disk, or even things like S3 buckets containing snapshots or actual EBS volume snapshots. So one thing you can do to try to immediately go figure out your posture as it relates to persistent kinds of threats is go see what your configurations are and go see if you have exposure due to things like leaked credentials or old credentials that are available somewhere. Wayne, did you have any other ideas on that one?
The only thing that I would add to that, because I think that's a great answer, the only thing I would add to that is to just analyze any previous incidents that you've had. You know, make sure that you're doing things like after actions, go and review those reports to look for things, look for commonalities, and look for things that have been repeated over time.
Yeah, one other thought there is one of the things we've worked very hard on in Fugue is visualization. And the reason we've done that is it's really hard to know everything you're running. And since a lot of the things that persistent threats use are counting on you not knowing about stuff. So at least with our tool, you can show visually the changes to your system over time and also everything laid out in a logical way. Hey, Wayne, could you stop sharing for a sec?
Sure.
Thanks. So just to show that briefly, let's just go straight back to that screen I had up, by the way, was showing the fixed remediation, but we've kind of moved on. It closed, it reopened the correct security group rules and replaced the tags. But here I'm going to show one of the ways you can do that kind of investigation to understand what's out there and how it's configured is to do this kind of visualization. And very often it's common for us when we show this to folks, and it only takes a few minutes to do it, for them to say, oh, I didn't even know I had that VPC network out there. And then we'll find an EC2 instance that's been, you know, abandoned for a year or something. Any other questions, Drew?
Yeah. So we're now using AWS Guard Duty and wanted to know how that will help stop data theft, or I'll throw vandalism in there too, but they said data theft.
Hey, Wayne, do you want to take a shot at that one?
Sure. So Guard Duty runs off of findings, and one of the findings of Guard Duty is it will look for just unusual API activity. So it really depends on the frequency and what your usual, what is usually happening within your organization. So if you're changing tags all the time, if you're modifying security group rules, those kinds of things, then the kind of threat, or the kind of threat that Josh has been talking about and what he demonstrated may go unnoticed. It's really only if it's actually an abnormal activity within the organization that guard duty might provide you some visibility there.
And I guess
The other thing I'll chime in on that with is a lot of the data breaches, especially those in S3, show up as pretty normal API calls. And that's one of the reasons why often when you see these publicly disclosed breaches, it's like months or even longer later that folks notice, because doing, for example, an S3 sync command between a production bucket and then headed toward, a bad actors bucket, that's not going to be a lot of API calls, necessarily, or even unusual looking ones. So I think, as with everything in cloud security, but especially data protection, prevention through proper configuration is a much better approach than kind of incident response after the fact, because the blast radius can be so big.
Great. Okay, next question. And I got to say, I love seeing the matrix terminology in these questions. What is the worst kind of impact that I can mitigate against with regard to episodic threats?
Boy, the worst kind of impact is the company ending variety, right? Like the, I forget the code. What was the name of the company? Wayne or Drew, help me out here.
Code Spaces.
Code Spaces. Yeah, so that was a scenario where not enough protections were put on the data, and the entire history of the data of the system was erased. And, that's kind of your crown jewels. So these things can be really, really devastating. And what you really want to do is make sure, so one of the things I've learned over my many years working in this space of cloud security, I was at AWS before founding Fugue, is you cannot, I just said a second ago, you should try to prevent. You should absolutely try to prevent. But you should also plan for the things you missed and couldn't prevent, and make sure you have resiliency so that the blast radius is limited to, it would be one thing as a startup to send an email to my customers saying, hey, we're really sorry, we had an outage for 4 hours or even 24 hours, but we're back up and running, and we've restored you to your state of operations as of 12 hours ago, or whatever the downtime began with. It's a very different thing to say, all your data's gone, we're sorry. So I think it's important to try to prevent, and in the case of these episodic things, to try to be resilient. In the case of data leaks, boy, that's a tough one, right? If you think about that Sony example, if your crown jewels get out there and there's like email traffic that doesn't look good for you and has a massive PR impact, there's not a whole lot you can do outside of like PR damage control there. But what you can do is make sure you're limiting permissions appropriately everywhere you can find those permissions. So for example, I'm the co-founder and CTO of Fugue, but I do not at any one time have access to our production environments, because I know I can become a victim. If I needed that access, I would ask it to be granted for a short period of time, and then I would relinquish it. So if you or folks on your team or folks upstream from you want more permissions than are necessary at any given time, that's a bad practice, and folks should be really worried about that, because it massively expands the blast radius potential.
Okay, next question. What can we do to detect malicious activity like crypto mining or running personal servers in our environment?
Yeah, so that's interesting. Like on a small environment, like the one I've got on screen now, it would be really obvious, if something appeared. There are a few things you can do. Of course, as the CTO of Fugue, I think in Fugue terms, there are probably other tools you could use to do similar things. One is, when you're thinking about policy as code, you can create, at least in Fugue, you can create custom rules using Open Policy Agent that will send notifications if things happen, like EC2 instances or other resources are constructed outside of the normal kind of chain of command and operations, or who have unusual characteristics. Like, for example, you might want to set an alert for anything that's spun up using GPU instance types that are both expensive and are by far the ones you want for crypto mining. So there are things like that. The other thing I would say is just, again, I'm a visual thinker, so I like to be able to like go back in time and compare and contrast visually, because big long lists of resources are harder to manage. But having some ability to consistently understand the posture over time of your cloud infrastructure in a way where you're going to notice the problems, and that's easier said than done. Again, I think the visual approach is the best one for that. I think we've got time for one more, Drew.
Yeah, no, and I was just going to add there too, when you're thinking about, employees running crypto mining servers or personal servers in your environment, they also may not be configuring those securely. So not only are they stealing your compute resources from you, but they actually may possibly be opening up security vulnerabilities in your environment that would let a bad guy get entry and do some damage or steal some data. I've got one more here that is, how can we get employees who are sort of lackadaisical about policy to just do better and change their behavior? That might be.
I'm going to send that one over to Wayne.
Over to Wayne, yeah.
Yeah, thanks. So you can try to do that at the margins. The best way is policy as code and policy enforcement, like we've been talking about. I mean, Josh has mentioned a number of times that humans are too slow at that. So as far as preventing those kinds of mistakes, that's really the name of the game.
That's a good way to end it. Thanks, everybody. As you can see on the screen, get started with Fugue for free for 30 days. Just go to fugue.co/go, and you'll be up and running in minutes and visualizing your infrastructure and identifying misconfiguration risks and policy violations. Obviously, reach out to us at hello@fugue.co. We'd love to talk to you and about how Fugue can help you manage your cloud security and compliance. And if you're going to reInvent, come say hi. We'd love to talk to you. Thanks, everybody.